Hello and welcome to Save by Design. I'm going to talk about the UX of secure banking. I am Dora Makszy. I live in Norway. I really do like books, and let's be honest, the Norwegian weather makes it really possible for me to read a lot of books. But it also makes it possible to go for a hike. And during a hike, I really do love to think about multiple problems. After a good hike, I do enjoy a good cup of coffee. Now, after I'm energized by a good cup of coffee, I deal with UI and UX, especially with data analysis and problem-solving part of the UX. And when it comes to my learnings, I really do love to speak about it. Now, today, I'm going to share a lot of stuff that I learned recently, and since this topic is going to be very heavy, I apologize first and foremost, but I'm going to look at my speaker notes because there's going to be a lot. Usually, I don't do that. I usually speak from the heart, but this time, I'm going to share a lot with you. This time, I'm going to talk about security bank application. So, let us begin. We will start with a seemingly simple authentication problem that quickly reveals deeper tensions between usability and security. We will look at what actually happened when different stakeholders tried to solve it and how complexity emerged. We will uncover the core insight. Authentication isn't a static feature, but a dynamic system involving to risk, uncertainty, and human behavior. We will explore principles that make security systems remain safe, even when things fail. We will see how these ideas translate into real design decisions and practical solutions. We will close with what this means for how user experience design teams and security teams should think and collaborate moving forward from day one. So this is the journey I would like to take you on today. Attackers rarely break your login system. They don't need to. They go after recovery, forgotten passwords, account resets, support calls. Basically the fallback paths, because recovery flows often have fewer safeguards and more human decisions. Therefore, your security flow is only as strong as your worst recovery flow. In a banking application, those moments aren't considered as edge cases. They are everyday reality. And designing them forced us to confront a deeper question. How do you stay secure when users forget things, devices change, and technology fails? In security, we often talk about the CIA triad: confidentiality, integrity, and availability. Confidentiality means only the right person gets access, and this is what we usually focus on, preventing unauthorized access. Integrity means only the right person can change things. In practice, it means actions that are legitimate. Transactions, changes, approvals when it comes to a banking application. Availability means the right person can get access to the system when they need it. And this is often underestimated. If legitimate users cannot access to their accounts, the system has already failed, regardless of how secure it is. Authentication directly affects all parts of the CIA triad. If it's too weak, confidentiality and integrity fails. If it's too strict or fragile, availability suffers and users get logged out. In mobile banking, we typically balance this by using 3 factors: device binding, something you have; biometrics, something you are; and a PIN or a passcode, something that you know. These aren't just login methods. They are mechanisms for balancing security and access. Deciding how they work together especially when things fail, is where user experience becomes critical. Authentication is where all these three can collide. The context for all this was actually very simple. We were working on a mobile banking application, and the goal sounded straightforward. Biometric authentication as a primary method, and a PIN as a fallback. That's a very common setup today. Users expect it, the platform support it, so it's kind of simple, right? But as soon as we started designing the real flows, not just the happy parts, reality showed up. Security requirements conflicted with usability. And suddenly that simple fallback turned into a whole ecosystem of edge cases and risk decisions. Those decisions are exactly where user experience and security must strongly align. Let me walk you through the 6 problems that we ran into. One of the first problems we ran into is very human. Security policies assume people will create unique access codes. People assume they won't have to remember them. If we ask users to create a PIN for the banking application, many of them will reuse the same PIN or passcode that they are using for their own mobile device. Now, from a security perspective, that creates a huge risk. If someone gets access to a device PIN, they might also get access to the banking application and thus the finances of the user. Now, the independence between authentication factors is completely gone. When credentials are reused, protection and access-related risk increase immediately. This pattern, humans reusing credentials, is behind many real breaches. In the Dropbox breach in 2012, attackers used passwords that employees had reused from other compromised devices. Once attackers obtained those credentials, they were able to access internal systems and eventually steal millions of user records. The technology didn't fail. The assumption that people use unique credentials did. This leads to an important question. Can we build security that doesn't depend on perfect user behavior? If a PIN is reused, the risk of balancing protection and access does increase. But that doesn't automatically mean the system is broken. If authentication factors are truly independent, then the system still has protection, even when one factor is weak. Security shouldn't depend on user perfection. It should depend on layered, independent controls. And that brings us to the real insight here. The problem isn't that users reuse access codes. The problem is that we designed systems that assume they won't. Resilient systems assume error. And once you accept that, the design approach changes immediately. Systems fail when they assume perfect behavior. Resilient systems assume mistakes. And once you accept that, that changes the design approach. Be honest. How many of you reuse one PIN somewhere? I assume so. The second problem is also very human, but a bit ironic. Biometrics are great for usability, and people use them all the time. But because people use them all the time, they forget their PINs. This often happens when users urgently need money. We had users who couldn't access their account because their biometric sensor was damaged. They weren't trying to hack anything. They just dropped their phone, but the system immediately treated them like a threat. When biometric authentication fails, which it will, users suddenly need a fallback they haven't used in months. And suddenly, we are in a recovery situation. In this case, do we allow a quick reset, like an email or a one-time password, which is good for usability, but potentially weaker for security? Or do we require something stronger, like a full KYC, know your customer process verification? Which is secure, but let's be honest, very frustrating, going through on taking photographs of your identity cards, and then NFC reading, and then selfie video upload, and then manual support. It's too much. When biometric authentication fails, users suddenly need a fallback. Yes. The core question becomes, what level of identity proof is proportional to the risk while still having good user experience? This isn't just about working authentication. It's about managing risk without breaking availability when people behave like people. Quick show of hands. How many of you have ever been logged out of your own account? Yes. When we talk about forgotten PINs, we are really talking about recovery. This is dangerous territory because recovery is authentication, but usually with fewer safeguards. Recovery is where attackers often win. If we make it too easy, we increase confidentiality risks. Attackers may be able to reset access. If we make it too strict, we damage availability. Legitimate users get locked out of their own money. Recovery decisions are always CIA trade-offs, and this is where design decisions matter. Instead of choosing between easy or secure, we can design progressive assurance. For example, if the user is on a known device, maybe an SMS or an email confirmation is enough. If the device is new, we might ask for biometric verification or a selfie check. And only if the system still isn't confident do we escalate to something stronger, like a full KYC. The most legitimate users recover quickly, while higher-risk situations still get strong protection. That's how we balance security and usability. Biometrics are great, until your phone decides that your face is suspicious. The third problem is about biometrics, and specifically third-party biometrics. In our case, we are using a recognition API for face recognition. It's a powerful service, but it's also continuously evolving. Models change, thresholds change, performance changes. And Amazon is very clear about one thing. They provide the technology, but how we use it, especially in security-sensitive scenarios, is our responsibility. So if the system fails to recognize a legitimate user, or worse, incorrectly matches someone else, the risk doesn't belong to Amazon. It belongs to us. Because when the system is uncertain, we cannot block the user. That hurts availability. We also can't blindly trust the result. That risks confidentiality and integrity. When biometric technology is uncertain, and it always is, the question isn't whether failures will happen. They will. The question is what happens next. Biometric systems produce probabilities, not certainty. That means authentication always contains some level of uncertainty. We can't remove that uncertainty with a single technical control. If confidence is high, authentication proceeds normally. If confidence drops, the system asks for another signal, like a PIN or another verification step. From the user's perspective, this feels like a smooth fallback. Under the hood, it's managing risk. This is where UX plays a critical role. It absorbs technical uncertainty and turns it into a predictable user experience. The fourth problem is about retries, and this is where things get counterintuitive. From a security perspective, limiting attempts makes sense. Fewer retries means less opportunity for brute force attacks. But from a human perspective, mistakes happen all the time. People mistype their PINs, or biometrics fail, or the sensors are broken. Now we have another tension. Security wants fewer attempts, while users need tolerance. And here's the surprising part. Retries themselves can become the attack vector. We've seen this in real incidents, like the Uber breach in 2022. The attacker didn't break the encryption. They obtained employees' credentials from the dark web, and while pretending to be IT support, they started to send multiple, absolutely maximum amount of multi-factor authentication requests, until a certain point when the user had enough and just approved one, and bam, they were in. So the technology still worked. The weak link was the human being. The deeper question is, are lockouts actually improving security or just moving the risk somewhere else? When we introduce lockouts, the intention is good. We want to protect confidentiality by stopping repeated attempts. But lockouts also damage availability. And when availability drops, new risks appear. Users get frustrated. They contact support. They look for shortcuts. And those moments, frustration and urgency, are exactly what attackers exploit through social engineering or recovery abuse. This leads to an important realization. Security that frustrates the users creates new vulnerabilities. Because the moment users lose control, they start making rush decisions we can't predict, and that's where systems become fragile. The fifth problem appears when something very common happens. A person reinstalls an application. From their perspective, nothing really changed, right? It's the same phone, the same person, they just deleted and reinstalled an application. But from the system perspective, everything may have changed. Device binding might be lost. The cryptographic keys might be gone. We are losing the possession factor, which directly affects confidentiality and integrity. And now we have to decide, do we trust this device again, or do we treat it as completely new? Platform differences make this even more complicated. On iOS, secure storage can sometimes survive the reinstall, which helps continuity. But on Android, reinstall often looks like a brand new device, which increases friction. Device binding is incredibly valuable because it strongly protects confidentiality and integrity. But when that binding disappears, for example, after a reinstall, availability takes a hit. Users face more friction, more verification, more uncertainty. When a system trusts that you physically control a device, that is a very strong signal of identity. It's much harder to fake possession than to steal a password. And this is where UX design plays a crucial role again. If we can restore continuity in the same way, recognizing the user, guiding them smoothly, escalating only when needed, we rebuild the trust without weakening security. Because when systems feel consistent and predictable, users trust them more. And that's why invisible continuity isn't just a usability improvement, it's a security mechanism. Users trust systems that recognize them because recognition reduces friction and uncertainty. When systems remember context, users feel in control instead of being challenged. Imagine you cannot access your money right now when you need it. Would you calmly read the instructions, or would you just tap anything in a hurry, right? The last problem is probably the most human one. When users cannot access their money, stress rises immediately. Under stress, cognition changes. People do not read instructions. They do not behave rationally. They just want the problem to disappear. Even perfectly written guidance may be ignored, and the experience feels broken, even if the security is technically correct. And this is not just a usability issue. It's also a security issue because stress is an attack surface. Social engineering works precisely by creating urgency and emotional stress, emotional pressure, pushing people into decisions that they wouldn't normally make. So the question becomes, how do we design authentication and recovery experiences that still work when users are anxious, frustrated, or in a hurry? Calm users make better and safer decisions. But when users feel blocked, confused, or locked out, they lose their sense of control. And once that happens, behavior changes. They start guessing. They rush the decisions. They contact support in panic. They may fall for social engineering. Under stress, their brain shifts from analytical thinking to reactive thinking. That is why they don't read. But it's not laziness. It's simple biology. What started as an availability issue can quickly cascade into confidentiality and integrity risks. That's why taking emotional stress into account during designing isn't just a UX concern. If we can keep users calm, give them clarity, show progress, and provide predictable next steps, we reduce risky behavior. So emotional regulation, helping users stay in control under stress, becomes a security control itself. Up to this point, we've talked about problems conceptually. Now, let's look at what happened in reality. This is the first workflow that was created by product managers. Their idea was to reuse an already existing flow for the B2B, business-to-business mobile application of the same bank. They didn't want to establish a new flow from scratch. They wanted to optimize, to patch this already existing flow. They knew that this is not a good enough flow for the users, but under time pressure, this seemed to be the best idea. This is where the flowchart started to look more stressed than the users themselves. At some point, the team realized that they must do something about the flow. It came from discussions between product management, security, compliance, and even legal professionals, with the goal of covering every possible case and edge case in one system. But this took weeks, even months, multiple discussions and meetings. And just think about it, this has become a very expensive problem, right? Multiple meetings for months, well-paid professionals getting nowhere. This is not just pointless, this is money. So this became a problem. Without UX design and development involved in the beginning, the result became extremely complex as well. Multiple branches, edge cases everywhere, hard to reason about, hard to implement, hard to explain to the users. Complexity is very dangerous, not just for usability, but for security. Complex systems always hide vulnerabilities and have inconsistencies and opportunities for mistakes. Complexity is the enemy of both UX and security. The reason is actually the same in both domains: people. When systems become complex, people stop understanding them fully. Designers lose the overview. Developers make assumptions while developing. Even when we were looking at the first flowchart, we could feel it. We started following one branch, and then another, and eventually we lost our train of thought. And if we can't reason about the system clearly, we can't secure it either. Complexity inevitably leads to gaps, edge cases that weren't considered, inconsistent states, unclear recovery paths, implementation mistakes. From a UX perspective, complexity increases cognitive load and confusion. From a security perspective, it increases the attack surface. Based on historic data, attackers don't break simple systems. They exploit the parts we don't fully understand. Simplifying flows isn't just about usability. It's about making systems predictable, understandable, and therefore more secure. Now, I know that 60 minutes is a bit too much, so just let it move a little bit and, bear with me. Yes, move yourselves, don't be shy. This is very important because this is helping for your brain. I mean it, come on. This is very important. Yes, stretching and, we are still human beings. And I know that we are in a security conference where everyone is very, very strict and yes, but we still need some fun, right? Because we still have a few minutes to really dig deep into this, because there are 4 more acts to discuss. So here comes realization. At this point, we had 6 different problems on the table. People reuse credentials. People forget credentials. Biometrics fail. Retries create risks. Devices change. Users get stressed. At first, they looked like separate authentication challenges. But when we stepped back, we realized they were all symptoms of the same underlying issue. We were treating authentication as a static technical feature, something with fixed rules, fixed flows, and predictable behavior. But in reality, authentication lives in a dynamic environment. The real problem wasn't pins or biometrics or retries. The real problem was that our mental model was too focused on one thing. That led to the realization authentication isn't just a login mechanism. It's a continuous risk management process involving human beings. And if that is true, then UX cannot sit on the top of the security as a presentation layer. UX is an enforcement mechanism because adapting to risk, uncertainty, and human behavior isn't optional anymore. It's necessary for the system to remain secure. If risk changes step by step, identity confidence should too. We do not jump from 0 to full trust in one moment. We build the confidence gradually. The system starts with the signals it already has. Maybe it recognizes the device. Maybe we confirm possession with a one-time password. Maybe we add biometric verification. Full KYC becomes necessary only when the system still isn't confident. Instead of forcing every user through maximum friction, we increase assurance only when the situation requires it. Why this matters is that it protects confidentiality and integrity while preserving availability for legitimate users. And this approach turns recovery from a painful experience into a controlled, risk-based process, which is exactly the kind of balance we've been talking about until now. This pyramid shows how identity confidence grows by layering independent authentication factors. At the foundation, we start with something the user has, for example, a trusted device, that already provides meaningful assurance with relatively low friction. To increase confidence, we add something the user knows, like a passcode. Then we strengthen it further with something the user is, biometrics or within biometrics Face ID or touch or fingerprint. Each layer is independent, meaning that this independence is what creates this strong security and ensures it. And only at the top, when the risk is high and uncertainty remains, do we require full identity proof, such as KYC. The important idea is that security doesn't come from one strong control. It comes from layering independent signals and increasing confidence step by step. Most legitimate users stay in the lower layers with minimal friction. Stronger verification only appears when risk justifies it. If authentication is really a continuous risk management problem, then security strength cannot be fixed. It has to adapt to context. Instead of applying the same friction everywhere, we adjust. This is how we protect confidentiality and integrity without unnecessarily damaging availability. We are dynamically balancing the CIA triad based on real conditions. This is exactly where UX designers and security experts start working together instead of against each other. And this became very clear when we looked at competitors. We saw very different decisions being made. For example, in some cases like Revolut, if the app had previously been installed, users could regain access simply with something relatively lightweight, like an email verification. When we discussed that within the team, internally, our compliance and legal teams and even the security teams had much lower tolerance for that level of assurance. Their view was simple. Email alone is not strong enough proof of identity for a banking access. We are protecting financial data. We are protecting a lot of very sensitive data. We cannot have this kind of risks for ourselves. This is a small company. So that revealed something important. These flows are not purely technical decisions. They are risk tolerance decisions. Every organization is implicitly deciding how much breach risk it is willing to accept and what impact it can absorb if something goes wrong. And those decisions directly shape the user experience. Authentication design isn't just about technology or UX. It's about organizational risk appetite. This table shows how authentication isn't just about factors, it's about decisions. This is a coordination model. If we read it from left to right, we move from low friction recognition toward high assurance identity proof. Each column combines 3 dimensions: the technical tools we use, the primary security concern at that stage, and the user experience goal we want to achieve. What this really shows is that authentication design isn't just a technical escalation. It's coordination between risk, security controls, and user experience. And that coordination is what allows the system to remain both secure and usable in real-world conditions. We usually design for success, the happy path. But security is mostly invisible when things work. Users only notice it when something fails. And failure is exactly the moment where everything becomes fragile. Users panic, attackers look for opportunities, and trust can collapse very quickly. Instead of starting with a happy path, we start with possible failure cases. What happens when biometrics fail? Credentials are forgotten, devices change, and confidence drops. If those moments are safe, predictable, and recoverable, the system stays secure. And when they are not, even strong technology can feel broken. So designing for failure isn't a UX technique, it's a security strategy. This visual shows what happens when authentication fails. On the left, failure creates uncertainty. Users don't understand what went wrong. They try random things, random actions, frustration grows, and the risk increases. On the right, the system stabilizes the situation. The user receives clear feedback, predictable recovery path, and controlled next steps. The failure itself doesn't disappear, but the system absorbs it instead of escalating it. And that stabilization is what prevents small authentication problems from turning into security incidents. Secure systems don't come from discipline alone, from one discipline alone. Product ensures decisions are aligned with risk tolerance and business reality. Security ensures that the system is failure safe. And UX ensures it's usable under real human conditions. When those three perspectives work together, we get secure user experience. When one is missing, the system becomes either unusable or vulnerable. This realization changed how we approached every decision afterward. Instead of asking what is the right authentication method, we started asking different questions. What is the current risk? What confidence do we already have? What signal do we need next? Authentication stopped being a fixed flow with predefined steps and became a system that adapts to context. And that shift matters because static systems eventually break when reality changes. Dynamic systems absorb change. We didn't have 6 problems. We had one wrong mental model. When we fixed that mental model, that was what allowed us to align protection with usability, not in theory, but actual practice. Resilience means the system stays safe even when components fail. And resilience is what prevents small authentication issues from turning into real problems. The real question isn't how to avoid failure. It's how to design systems that stay safe when failure happens. A few principles consistently help with that. First, start with designing for failure. Authentication becomes visible the moment something breaks, so that moment has to be predictable and recoverable. Second, remove dead ends. When users hit a wall, they will improvise, and improvisation immediately creates risk. Third, reduce the need for credentials and use familiar patterns. The less cognitive effort tasks require, the fewer mistakes users make. And finally, let friction follow risk. Low risk should feel easy. Higher risk requires another verification, but only when necessary. All of this builds resilience. There is a common assumption that better usability means weaker security. But what we've seen is actually the opposite. Good UX increases the probability that security used correctly. If systems are predictable, understandable, and recoverable, users do not need to invent workarounds. They do not write things down. Do you remember how many people used Post-its around their displays, right, to store their passwords? This is a classic example, but it actually happens at every single company. This is just crazy. And if the systems are predictable, understandable, and recoverable, the users won't panic. They don't bypass controls. And that is directly improving security outcomes. Confidentiality improves because unsafe behavior decreases. Integrity improves because actions are clearer and confirmation is stronger. And availability improves because recovery is smoother and less disruptive. Good UX isn't a compromise with security. It's one of the mechanisms that makes security effective in the real world. The strongest control in your system is that one people actually use. We've talked about problems, patterns, and principles. Now I want to show what happened when we actually applied them. Because theory is interesting, but implementation is where security either succeeds or fails. Remember the original huge chaotic flow that I showed you before? Now you see what happened when UX stepped in. Instead of one massive flow, we separated the scenarios. Each scenario became simpler, easier to reason about, easier to follow, and thus easier to secure. And we had to realize security problems often look complex because we are mixing different situations together. When you separate the context, both UX and security improve. Once we changed the mental model from static feature to dynamic human risk system, the implementation direction became much clearer. For us UX designers, it made sense to separate these flows. This is how we could think it through. This is how the flows were simple enough so that we could think of potential security failures. But with this, we also achieved one more thing. The system could adapt. When risk was low, known device, familiar behavior, access felt fast and effortless. When uncertainty increased, new device, unusual context, the system added verification. And when the risk was truly high, we escalated to stronger identity proof. From the user's perspective, this doesn't feel like more security. It feels like the system understands the situation. And that's the key idea. Adaptive security removes unnecessary friction. We weren't choosing between usability and protection anymore. We were adjusting security strength to match reality, dynamically preserving access while maintaining trust. We designed predictable recovery paths, progressive escalation, and clear guidance. We also adjusted retries and lockouts, not just to block attackers, but to avoid pushing legitimate users into panic or unrealistic, unsafe behavior. And something interesting happened. By making failure safe, the overall system became more secure because small problems stopped turning into security incidents. What we really implemented wasn't just new flows. We implemented resilience. We protected the system with layered, independent factors. We supported the human with clarity and familiarity. And we adapted security strength to risk and confidence. That allowed us to solve the 6 problems while still preserving confidentiality, integrity, and availability. This is the key idea. Security works best when systems are designed for how humans actually behave, not how we wish they behaved. And that leads directly to the final takeaways. After everything we implemented, the biggest lessons weren't technical. They were about mindset, about how we think about users, how teams collaborate, and about how security is designed from the start. These are the ideas I believe matter most when we are moving forward. One of the biggest takeaways from this project is simple. Humans are not the weakest link. They are part of the system. People reusing credentials, forgetting things, getting stressed and making mistakes, none of them is unusual. It's natural. It's predictable. When we design with that mindset, when we design for real behavior, not ideal behavior, we reduce unsafe workarounds, improve the recovery, and ultimately improve confidentiality, integrity, and availability. UX and security are often seen as contradictory forces, like security adds friction while UX design removes friction. In reality, both disciplines want the same thing: safe outcomes. Security understands threats and controls, and UX understands cognition, emotion, and behavior under stress. Both disciplines are risk management, just from different angles. When those perspectives work together, we get systems that are both usable and secure. When they don't, we get systems that are either unusable or vulnerable. Collaboration isn't optional. It's architectural. What this really comes down to is when decisions are made and assumptions behind them. Security often gets designed first, and then UX designers are asked to make it usable afterward. Remember that huge chaotic graph that I showed you? That started when product management approached me, actually, and they just told me, okay, we need screens for every single little box. And I was like, no, this won't work. And they didn't really understand why. They got used to the designer saying, okay, yeah, sure, we are going to deliver those screens for you, and then we will see how it works. But when I saw that chart, I was like, nah. And that was the point when they involved me and backend developers and security experts, and then we started to think about real-world scenarios. We are all using mobile banking applications. So we actually started to compare them. Okay, what does Revolut do? What does Wise do? So we compared these use cases, and we saw that this can actually be simple if we want them to be. And that led us to the separated scenarios. When we finally understood that these flows can be simple because they are separated according to their context, that was the point when we actually reached a breakthrough. We've seen that this order that security is asked afterwards doesn't work well anymore. Authentication today isn't just a technical control. It's a human interaction under uncertainty. So UX couldn't sit on top of security. It should be involved when security is defined, when we model threats, when we define recovery, when we decide acceptable risk, when we design failure paths. That is how we build systems that work not only in theory, but reality. And when systems work in reality, the users, all of us, we will trust them. We've been talking about authentication, risk, uncertainty, and design decisions. But underneath all the technology, something much simpler is happening. Every security control eventually meets a human being, a person entering a PIN, a person responding to a prompt, a person trying to recover access, a person under stress, in a hurry, or being confused. And in those moments, the outcome isn't determined by cryptography alone. It's determined by whether the system guides the person safely or leaves them struggling. That's why user experience design isn't separate from security. It's part of how security actually works in the real world. Because in the end, security only works if users can succeed. Thank you. One more thing, since we do have a little bit of time, if you do have questions or you do not agree with some part, just reach out to me on LinkedIn or right now, and then I will try to answer. I don't know if you noticed, but in the beginning, my slides were a little bit mixed up. That was due to a very interesting story. I will tell if someone is interested. But I'm sorry for that. I usually speak from the heart, and I usually use slides just to support what I'm saying. But right now, it was very hard to bring it together. But still, I do hope that I could give you something with this talk. Thank you.